Alright, let's solve the inequality. X over 6x minus 9 is less than or equal to 1 over x. So if we want to solve this inequality, what we want to do here first is let's move all the terms to one side. So I'm going to move the 1 over x to this side. You have to make the other side equal 0, so minus 1 over x is less than or equal to 0. And in order for us to solve this inequality, what you need to first do here is make sure that the denominators are the same, right? So we need to actually look for a lowest common denominator, and that's as simple as just multiplying the two factors or the two terms on the denominator together, right? So we can basically figure out that the lowest common denominator is 6x minus 9 times x, right? So I'm going to make them equivalent fractions with this denominator. So for the x over 6x minus 9, I'm going to multiply this by x and this by x to create its equivalent fraction, x squared over x times 6x minus 9. So I'm just going to keep down the denominator. I don't have to expand it, right? And then the 1 over x here, I'm going to multiply this by 6x minus 9. I'm going to do the same thing for its denominator, and you get 6x minus 9 times x times 6x minus 9. Okay, so now you can see that the denominators are the same, and what you can get here is I'm going to make a collective denominator, x squared minus 6x minus 9. Make sure that when you do the subtraction, you put a bracket around these two terms. This is a binomial term. And this is over x times 6x minus 9. Now, this is basically less than or equal to 0. At this point, I'm going to simplify this rational expression here. And the way I'm going to do that, I'm going to simplify the numerator. So we have x squared minus 6x plus 9 over x times 6x minus 9 is less than or equal to 0. Now looking at this numerator here, you can actually note that this is factorable. So the way we're going to factor this, this is actually a perfect square trinomial. So if I factor this, two numbers that add up to negative 6 that multiply to positive 9, you can do negative 3x minus 3x plus 9. So you get x minus 3 minus 3x minus 3. Right? I usually just factor quadratic trinomials by means of the product sum method, or also known as decomposition method. So you get x minus 3 squared. Okay, so now you see that your rational expression here, your rational inequality actually, x minus 3 squared over x times 6x minus 9 is less than or equal to 0. Now what you want to do here is you want to solve for your rational inequality. Now to solve for your rational inequality, you actually need to find your critical points, right? So what we did here was we simplified a rational expression, right? Now we need to find our critical points. Well, specifically our critical numbers. Now the critical numbers are values of x that will include x-intercepts as well as vertical asymptotes. So our critical numbers here, x can be equal to 3, okay? That's basically one of our x-intercepts. And it includes also, so this is our x-intercept, but it also includes our vertical asymptotes. X is equal to 0, as well as 6x minus 9 cannot equal 0. Move the 9 to the other side, 6x cannot equal 9. X cannot equal 9 over 6, which is equivalent to 3 over 2, right? So this cannot equal 3 over 2 as well. So these are basically our points. Now you have to understand that this is greater, it's less than or equal to 0. So it's less than or equal to 0. What that means is inclusive of 0. So we know that the x-intercept is fair game, so it can be inclusive of the x-intercept, but it can never be inclusive of the vertical asymptotes because the vertical asymptotes don't exist in the function, right? Or in the rational expression, right? So think of this as a restriction. And what we want to do to figure out our intervals, I'm going to create a number line. Okay, so generate a number line to determine the intervals using the critical points, or the critical numbers. Okay, so I'm going to generate my number line here, and I'm going to plot the intercepts as well as the vertical asymptotes. Now for the intercept, I'm going to make it inclusive, so this is 3, it's inclusive of 3, but for the vertical asymptotes, it's not going to be inclusive, right? So we're going to have a 0 here, so this is, this is 0, and we're also going to have, you know what, we're going to move the 0 out here, right? So this is 0, it's non-inclusive, and we're also going to have at 3 over 2. This is non-inclusive. Okay, this is negative infinity. This is positive infinity. Okay, let's figure out what these intervals are. Okay, so just do that in blue. So this interval here is negative infinity to 0. This interval here is 0 and 3 over 2. This interval here is 3 over 2 and 3, but it's going to be inclusive of 3, but not inclusive of 3 over 2, because that is a vertical asymptote. And this interval here, excuse me, this interval here is 3 in positive infinity. Okay, wait, sorry. This is going to be inclusive of 3. Okay. So now that you have your intervals, what you want to do here is you want to create a table of intervals. So let me design that table of intervals here. Let's use, you know what, let's use gold here. Okay, so from doing that, okay, I'm going to put my intervals on top in this upper row here. Okay, so we have 1, 2, 3, 4. We have 4 intervals because we have 3 critical points, right? We usually have one more interval than critical point. X belongs to all of this, and I'm going to put down negative infinity and 0 here. Okay, so we have 0 and 3 over 2 here. We have 3 over 2 and 3, so this is going to be inclusive of 3 but not inclusive of 3 over 2. It's greater than 3 over 2, and it's going to be greater or equal to 3 and less than positive infinity. Remember that infinity is never going to be inclusive because infinity is not a finite number, right? It's a continuum. Okay, so now that we have all of these intervals, what we're going to do is put down our factors. So our factors, our numerator is x minus 3 squared. We know that any factor squared is going to be positive across the board, so it's going to be positive across the board. We don't have to worry about that anymore. Now, we also have 1 over x, and we have 1 over 6x minus 9, okay? And this is, we'll call this our expression r of x, right? So r of x is basically this full thing here. Okay, so this is r of x, right, just for simplicity's sake. And we're trying to solve this, this rational inequality where it's less than or equal to 0, right? So let's take a look at 1 over x. So if we take in value between negative infinity and 0, let's say x is equal to negative 1, and this is negative. When x is equal to negative 1, we have negative 6 minus 9. This is also negative. And then we have 2 negatives and a positive, so that gives us a positive. So this is greater or equal to 0. That's not one of our solutions, right? Now let's take a look at 0 and 3 over 2, right? So in this case, if we're looking at 0 and 3 over 2, sorry, this should be just greater than 0, not greater or equal to 0. Okay, there's no value here that would make it 0. Now, because 0 is a vertical asymptote, now between 0 and 3 over 2, let's pick a value. Let's do x is equal to, 3 over 2 is 1, so I'll let x equal 1, right? Sorry, 3 over 2 is 1.5, so I'll let x equal 1, because it's in between that. Now, if x is 1, then this is positive, and this is negative. So now we're going to get us to negative. This is greater or equal, well, specifically this will be greater than, less than 0, right? It'll be less than 0 because both of these cases are vertical asymptotes. Now, between 3 over 2 and 3, this is basically between 1.5 and 3. Let's say x is equal to 2. If x is equal to 2, then this is positive, and this is positive. If these are positives, then this also would be positive. So this is going to be greater or equal to 0. It's greater or equal to 0 because if x is equal to 3, we know that's an x-intercept, and it'll give us 0, right? And between this point, 3 and positive infinity, right? Let's say x is equal to 4. If x is equal to 4, then this is positive, right? And we can see here that, I think 2, 4, yeah, this is positive. So this will also be positive, so this will be greater or equal to 0, okay? Just to make sure that we didn't make a mistake here. Yeah, it seems like it checks out, right? So this tells us that the only interval that is going to be less than 0 is going to be 0 and 3 over 2. Right, so therefore x can belong to 0 and 3 over 2, or x can be equal to 3, right? And when x is equal to 3, then we know that this function here would become 0. So that's really the idea behind it, right? So you just have to use a table of intervals, and this is our solution. So all these values will satisfy the inequality. Okay, so that's the idea.